Okay, hi, I'm Mrs. Yanni, and I'm going to talk about multiplication, which is chapter 4. And in this little video, I'm going to talk about the meaning of multiplication, the different ways that we've talked about representing multiplication, the properties of multiplication that are pretty significant, and of course the standard algorithm and the other algorithms that we can use in talking about and multiplying numbers. Alright, so let's just start with the meaning of multiplication. We know that a times b also can be written as a with this notation times b, or this notation a times b. And this can simply just mean the number of groups times each group. So for example, in this example, we have 3 groups and there are 4 in each group. So we could simply model 4 times 3 in this fashion. Before I go on, I just want to remind you that you should know these terms here, product, factor, and multiple. And factor and multiple are often confused by students and by some of you. So make sure that you know the difference yourself. Alright, so let's go ahead and talk about the representations of multiplication, starting with an array. An array is just simply a rectangular arrangement of things in rows and columns. And as you can see here in this diagram, I have 3 rows of 6. And so the way that we look at it is we can say, well, I have 3 groups of 6, or I could look at it the other direction and say I have 6 groups of 3 if I'm looking at the columns. So this, of course, in essence, is a great way of modeling the commutative property, which we're going to get to on the next slide. Let's talk about an ordered pair. A lot of times we use an ordered pair in multiplication to figure out how many pairs of things can be made. So for example, if I wanted to know how many cheese sandwiches I can make, if I have wheat and white and rye bread with cheddar, Swiss, and American, then I can simply make what is called a tree diagram, and that's what you see here. And it will help me make an organized list. And so by making a list now, I can see that I have 3 groups of 3, and so I'm easily able to model that multiplication problem in this way. The third representation that we're going to talk about is multiplicative comparison. And this is a relationship it shows a relationship, a multiplicative relationship between 2 quantities. For example, if I have 7 of something, and my friend Joe has 4 times as many as I do, then I can show that using this bar diagram, 7 and then 4 times that 7. So I can represent 4 times 7 in this fashion, in a comparison fashion. Okay, so next we're going to talk about properties of multiplication. We're going to talk about, we're going to talk about associative, commutative, and the distributive property. So we're going to start with the associative property of multiplication, which simply states that a times b times c can also be understood as a times the quantity b times c. So in other words, regardless of what factors you multiply together, you're still going to have equivalence here. So the way that I'm choosing to show you that is by showing you this rectangular prism that is 3 by 4 by 2. So if we chop this rectangular prism up sort of right here, and we kind of cut it right there, then we will have 1, 2, 3, 4 layers, and each layer is a 3 by 2 layer. So we're going to need 4 of those chunks, and each chunk is a 3 by 2 layer. So we can see that 4 times 3 by 2 can be represented. That expression can represent this rectangular prism. But at the same time, we could chop it up this direction. Well, actually, there are several different ways we can chop it up, but just for the purposes of this, we can also chop it up this direction vertically, and that's what I tried to draw here. And if we do that, then we're going to need 3 of those, and those that I'm talking about are 2 by 4 pieces. So we're going to need 3 2 by 4 pieces. So as you can see, both of these, regardless of the way we cut it, these 2 expressions will both give us a completed rectangular prism. So now we know that 4 times 3 times 2 is equivalent to 3 times 2 times 4. So it's back to that associative property. Regardless of the factors multiplied together, we're still going to get equivalence. Alright, commutative property. We already talked about that a little bit with the array, so we're just going to talk about it quickly here. Simply means that a times b is the same as, or is equal to b times c. So here in this rectangular array, you can see that holding this rectangle this direction horizontally, we can see that we have 3 groups of 6. But then if we take that same rectangle and turn it, we have 6 groups of 3. So a times b is equal to b times c. And lastly, the distributive property. And this was that fun property that will allow us to show basically both forms of writing this equation. So we know that the distributive property states that A times the quantity B plus C is equal to AB plus AC. And if we make a rectangular array here, we can show that. So we're showing A times B plus C, sort of thinking about length times width. So A could be our width here, and B plus C would be our length. So we're just going to multiply A times B plus C. And in this section, we multiply A times B and get AB. In this section, we multiply A times C and get AC. So now we can see that A times B plus C is equal to AB plus AC. Here's one that's maybe a little more complicated, and I'm using numbers here to show 22 times 11. To do this, I'm going to think of 22 as 20 plus 2, and I'm going to think of 11 as 10 plus 1. And so now, with my rectangular array, I have a 20 plus a 2 times a 10 plus a 1. And now what I'm going to do is I'm going to multiply the partial sums, or the partial products, excuse me. So 20 times 10 gives me 200, 20 times 1 gives me 20, 2 times 10 gives me 20, and 2 times 1 gives me 2. And then what I simply do is add up my partial products to get my total product. So I'm adding up 200 plus 20 plus 20 plus 2, and I get 242. All right, and lastly, I'm going to fall this time. So lastly, we're going to talk about algorithms. And we're just going to talk really briefly about this because we all know the standard algorithm for multiplication, but we're going to talk about why that works by looking at the partial product algorithm, and then talking just a little bit about how you might model that with an array or with blocks, which gets definitely more complicated the larger the numbers that you use. So let's look at the standard algorithm here for 38 times 6. The way that we all learned it was just take 8 times 6 and you get 48. So you put the 8 down and you carry the 4. That's usually the terminology that we used. And then we multiply 6 times 3 and we get 18, and we add 4 and we get 22. So we're going to talk about why that works by looking at the partial product algorithm. So when we multiply 38 times 6 in the partial product fashion, we're going to take 8 times 6, or multiply our units place first, and we get 48. And then multiply our 30, which is what we have here in the tens place, times our 6, and we get 180. And then we get 228. So what we're doing is we're basically taking this section and we're shortcutting it when we use the standard algorithm. So that's a little bit hard to see in this 2-digit by 1-digit multiplication, but I think you'll be able to see it here in this 3-digit by 2-digit multiplication. So here I did the standard algorithm. I used that to multiply 764 times 58. And I started with this. 4 times 8 is 32, carry the 3. 8 times 6 is 48 plus 3 is 51, carry the 5. 8 times 7 is 56 plus 5 is 61. Then I put down a 0 placeholder, and I multiplied now my 5 times my 4, my 5 times my 6, my 5 times my 7. And then, of course, I add up my 2 rows here, and I get my final product. Okay, so if we do this the partial product way, it actually gets pretty long, and I ran out of room, so that's why you see that I had to carry it over here. But I hope that this makes sense, because what I'm going to first do, of course, is multiply my units place. 8 times 4, and I get 32. Now I'm going to multiply my 60 times my 8, and I get 480. And just a side note, what I really like about partial product multiplication is just what happened a moment ago. I didn't say 6 times 8, I said 60 times 8. So it reinforces place value in the decimal system. All right, so we just did 60 times 8. And then lastly, we're going to do 700 times 8, and we get 5,600. And then what we're going to do is we're going to add these up. And the only reason I'm adding these up now, instead of continuing with my partial products, is because I want to show you how this works. So if I add up these 3 partial products, I get 6,111. And if you look over here, that was my initial first step in the standard algorithm. So really, the standard algorithm is taking these partial products, and it's just basically making a shortcut. Now I'm going to continue because I'm not done with my partial product multiplication. Now I have to take 50 times 4, which is 200, 50 times 6, which is 3,000, and 50 times 7, which is 35,000. And then I'm going to add up those partial products, and I get 38,200, which, of course, if you look back over here, that's what I got the second on the second row here for the standard algorithm. So, of course, when I add up these 2 rows, I get 44,312. And when I add up all of my partial products here, I get the same answer, 44,312. I just added the array up here because sometimes it's great to model multiplication with an array, and you could use base 10 blocks, or you could use other types of blocks. You could even use bundled objects. So if you think of these as bundled objects, you're just going to multiply parts times parts. And so what I did here is I took my 38, so I've got 10, 20, 38. So think of this as a bundle of 10, a bundle of 10, a bundle of 10, a bundle of 8, and I'm multiplying that by a bundle of 6. So I have to multiply each part times each part. So a bundle of 8 times a bundle of 6 gives me a bundle of 48. A bundle of 10 times a bundle of 6 gives me 60, and I do that 3 times. And then I'm just simply adding up now what I have in my total bundles. 48 plus 60 plus 60 plus 60 is 228. You could do the same thing with 764 times 58, but like I said earlier, the larger your numbers, the more difficult your array model or your diagram type model gets. And in this case, you can see that I would have had to have 700 plus 60 plus 4, so it would have been way over here off the board, times 58. But because basically, like I said here, what I'm doing is I'm multiplying each place value by each other place value. 700 times 50, 700 times 8, 60 times 50, 60 times 8, 4 times 50, 4 times 8. And that's what we're doing when we do our partial product multiplication. So it's really the same thing. We're just looking at multiplication different ways, and I hope that helps, and I hope it makes sense. And make sure you ask questions if it doesn't. Thanks.